And it seems a lot of us are from Muljan, which is also pretty cool. Did my undergrad in Muljan. Cool, so to begin with, I think you all saw this comment, show of hands. Who here has coded before ever? Okay, just below half the crowd. Who here has used R before ever? Okay. Who here has used R extensively, which is very nebulously defined, but more than, let's say a week's worth of work? Okay, so this is the right crowd, given that this is an intro lesson. And I mean, it's awesome to see you guys all here and ready to learn R. So does everyone have RStudio installed and open? If you do it, your screen should look something like this. In the interest of time, if you, oh yeah, what's up?
Sorry, do we close this door next to the screen? Oh,
Yeah, totally. If you don't have RStudio installed, I would flag down Madeline or Elliot, but it seems most people do, which is awesome. Okay, so to begin with, a few words about R itself. R is a programming language, which we all know. It was primarily developed for statistical computing and data analysis. But I mean, of course, you could use it like any other programming language and do stuff above and beyond that. But the consensus is that it really is best at stats, data analysis, data visualization. That's kind of its bread and butter. So with that in mind, this will differ a bit from your traditional intro lesson. So something like an intro to Python lesson might go over like object types and loops and that kind of standard stuff. This is going to be slightly different in that we're going to touch really briefly on the fundamentals on working with objects and assigning stuff, but then we'll get right into actually importing and working with data. And I promise it's not as big a jump as it sounds like. But the idea here is that this will make this lesson perhaps more directly applicable to your research. Like you might know how to write a loop and then go back to your work and be like, I have no idea how to implement this. Whereas working directly with data might be a little more immediately useful. A caveat, he's not actually here, but this lesson was mostly developed by Luke, who is a cool person from UofT Coders. He just finished his PhD. That's probably why he's not here. I feel like I should mention that because this is being live streamed and I want that on record. So if you miss anything, we do have a live stream up or a recording up afterwards, so you could like always watch this again whenever you want and hear my beautiful voice. Okay, so does everyone have RStudio open? Sweet. Did everyone run those two commands up there at some point? Awesome. So just a quick tour of RStudio before we actually get into things. So you notice it's split into 4 what are called panes. And over here, we've got the source editor where you could just write code. This is kind of where you'll be working most of the time. You can write code, you can edit it however you want, and then you can run it whenever you want. And you can write entire scripts and the like in here. This here is the console. This is where you directly interact with R. So, speak of the devil. That's Luke, everyone. I'll let everyone settle. Or I'll continue. Okay, so the console is how you directly interact with R. What we'll mostly be doing in this lesson is sending code from the editor to the console. So this is a proof of concept because apparently this is what you're supposed to do every time you start a new programming language. We're going to print hello world. Yay. So this is what you traditionally see in the console. This arrow here signifies that we're writing code, and the output in R looks something like this. Down here is the environment pane. As you create variables, which we'll talk about in a bit, these are like shown there kind of for reference. But I mean, we won't be referring to this a lot, so I'm going to minimize it here. And same goes for this here. So I'll minimize it a bit. So this last pane is like kind of multi-purpose. You can see the files within your current working directory. This is where plots will show up, and a bunch of other things we'll be going through. So to begin with, so this is R. R is cool, and hi. And to begin with, when we're working in R, we're mostly working around this idea of objects. So what I mean by that is, to put it differently, actually. So I'm just going to write out code. So I wrote this in the editor, and I can send it to the console by pressing Control Enter. So I'm going to do that right now. And that got executed over there. What we did here was we assigned the number 1 to the variable x. So whatever's on the right gets assigned to the left, hence that funky little operator. And now, when I go print x, you can see that I've got the number 1 stored in there. Also, just feel free to shout out questions anytime, or let me know if you missed something. So what we did up here is we assigned something to a variable, and what we did here is we ran a function on it. Print is what's considered a function. This is us telling R to do something with what we've defined in our workspace. So the anatomy of a function generally, everything okay back there? Of a function generally is the name followed by brackets, and inside the brackets are what we call arguments. This is basically what we're feeding the function, what we're telling it to do its work on. And honestly, these two are like the main fundamentals that you really need to know for this lesson. One last thing is that sometimes arguments will have, a function will have more than one argument, or like a bunch of different defined ones. So for instance, a useful function is seek, which will take a from argument and a to argument and give you a sequence of numbers between those two. So in instances like these, for like these more versatile functions, we can define the arguments within these brackets. So I could go from 1, 2 equals 3, and then run this, and then R prints out a sequence from 1 to 3. But these are both functions. There's nothing particularly different about them. Just sometimes we want to make these arguments explicit. Everything makes sense so far? Sweet. Okay. This is the boring stuff. It ends here, I promise. Now that we've got the fundamentals figured out, also just one thing I should let you guys know, you can comment your code. This is useful for keeping notes using the hashtag. This is a comment. I can't type. And everything to the right of the hashtag will not be run as code. So this is a nifty way to keep notes for yourself. So today, this is pretty much all we're going to do in the way of basics, and we're going to jump right into working with data. So different objects in R there are different object types in R. So what we did here, when we saved the number 1 to x here is what we call a numeric object, because it's storing a number. For those who might be a little more familiar with clear lingo, this is analogous to a float. And then same goes for something like a string. So if I go, I don't know, test is equal to, or here I'm saving the string. A string is like a sequence of characters into the variable test. I'm going to run that to save it, and then when I run class on it, it's a character. And that's what R calls strings of text. What we're going to concern ourselves with, though, is this object type called a data frame. And a data frame is basically a way of storing table formatted data within R. And data frames are like the bread and butter of I would say, most of what our users do. Might be overgeneralizing, but and the data frame we'll be working with today is called Swiss. So to have a look at Swiss, you can just type in Swiss because it's already built into R, because R is cool like that, and you can just run that. And you'll notice your console gets like polluted with all this data over here. So obviously looking at it in the console is not the most conducive thing in the world, but we'll fix that in a second. Before we can get to like playing around with the data and doing cool stuff with it, often in research what we usually do is import data into R first. And here we kind of cheated because Swiss was already built into R. So I'm just going to show you how to do that real quick before we'll get into doing stuff with it. So what we'll actually do is save Swiss to a file and then read that file back into R, which seems completely redundant, but this is basically just my way of showing you guys how to actually pull data into R when it's not already there. So to write a data frame object, also if you don't believe me, you can run class on Swiss and see that it is a data frame. But to write that to a file, we use the write CSV command, which will write it to a comma-separated values file, which is like a flat file format for storing data that some of you guys might have seen around. So we would go Swiss, that's the first argument because that's what we want to save, and then the name of the file, which we'll call swiss.csv, because why not? Then once we run that, I kind of already have it there. But if you have this pane set to files, you'll see swiss.csv show up there. And then you could read that back in using the read.csv function. Here you just go quotes swiss.csv. Now if you actually run the, oh, what's up? Oh, from the source editor, you just use Control Enter. So that'll run the current line of code your cursor is on. You could actually highlight like multiple lines as well, and also run Control Enter. Make sense?
Command Enter.
Command Enter? Oh, sweet.
I think also Control Enter works.
Both work, yeah. Yeah, because Control Enter kind of sucks on MacBooks. Oh, sweet. Control R does just the line, not the whole thing? Sweet, okay. Caveat, I actually changed it to Shift Enter because it's easier for me, but you can do that in the settings. Yeah, what's up?
Is there a way to terminate outputs? Colon.
Not that I know
Okay.
of. Luke might know that. But generally, we won't be doing stuff like just printing Swiss. We'll be saving it to objects.
Yeah, that's the reason. It's just I'm used to other
I know, MATLAB and stuff, yeah. No, I get you. Nothing I know of in R. Anyhow, okay, so back to reading in this file. So if we just run this command itself, it'll spit it out in our console, which is obviously useless to us. So what we want to do is save it to an object, a variable. And we'll call this df, which is short for data frame because I'm super creative. And again, we'll use that assignment operator. Can everyone see this all right? Let me just add some white space down here. Let me know if you need me to scroll back up. Yeah? Okay. Sorry. So does everyone get what happened here? We read the file in, and then we save that to an object called df. Make sense so far? Sweet. And just to make sure, we can check the class of df. And predictably, it is, oh God, that's not right. Did I do something wrong?
No. Did you say assign?
Yes. Oh, silly me. Pretend you didn't see that. df is a function. It's a freedom.
It might be better just to call it DS.
Yes. Okay. Sorry, we're going to change it to DS for reasons that I can explain after this. You know, in class DS, it's a data frame. Okay, now the fun actually begins. So we've established that looking at just printing out the data into our console is kind of useless. Doesn't really help us. But fortunately for us, RStudio has a really nice viewer built in that allows us to look at data frames in a much, more visually pleasing format. And this is with the view function, with a capital V, which is kind of abnormal. So make sure you have that in there. Things are case sensitive in R. So if you go View DS, it'll open a new tab up there. So you notice the tabs here. And now you can actually look at your data in a much nicer format and get a sense of it. Sure, sorry. So if you run the view function with a capital V on your data frame, it'll open a new tab up here. And then you can look at your data frame like in this much nicer format.
You can also go to environment.
True. Yeah. You can also click it down here if you've got this open. There, right? Yeah. Anyhow, I'm going to shrink this again. Sweet. Did everyone get that step all right? No? What's going on?
So I got up to class Swiss and then write work and then the DS.
Oh. Is
So
the,
this was fine.
Okay.
Below that,
this did not work. Probably not having a look.
error unexpected.
Okay, anyways, I'll move on in the meantime. So there's multiple ways to, oh, what's up?
I'm just a little confused. Is the objective of this right now to make it sort of frame?
Of this whole lesson or what we did exactly just here? Right now we just loaded it into R, and right now we're just looking at it. Load in data. Yeah, just a flat file that contains our data. Like a flat file is like a text file, basically. Technically. Yeah, usually it's generated by like a program, let's say, or something, and then we want to load it into R to analyze it. Yeah. Are we done for time? Awesome. Okay. I'm going to speed it up just a little bit. Bear with me. So there are multiple other ways to look at our data because view is not always the most useful one. So one that we very often use in R, because it's a very handy way to just like peek at your data frame, is head. And what head will do is it'll print out the first 5 rows of your data frame, or I guess it's here, whoops, into the console. So this is a good way to like have a look at the structure of it without necessarily printing out like all like 200 whatever rows we have in the data frame. Finally, there's also str, which is short for structure. And this prints out a, oh god, that probably looks better in your consoles than it does mine. But it prints out like a nice linear explanation of what's in each column. So you'll notice, for instance, that the fertility column has numeric data, whereas the examination column has integers. And that can be useful to know sometimes. Finally, in terms of looking at our data, instead of pulling out the whole data frame, if we just want to look at the column names, we could use the names function. And that'll just print out the names of our columns. There's also the call names function, which does the exact same thing. I think there's some under the hood differences there, but just pick one and go with it, honestly. Sweet, everything makes sense so far? Any questions? Great, okay. So now that we've looked at our data, which, just for context, is I believe some measurements from counties in Switzerland. It's got some fertility, it's like got socioeconomic measures like fertility, agriculture, I don't know what examination is, education, how many people are Catholic. And now we're gonna actually like manipulate this data. We're gonna wrangle it to get cool insights out of. And for this, we're gonna import the dplyr library or package. So this is something we installed earlier on, if you remember, with this install packages command. So now we're actually gonna use it. And so this is the command. And what this tells R is we're gonna take, so sorry, to backtrack a bit, dplyr contains a bunch of really useful functions for doing stuff with data frames. That these are not necessarily available in base R, but by importing dplyr, we can start using these functions. And there's like a whole host of packages outside of dplyr, and these really augment the functionality of R and make it like a really powerful language. So when we run library on dplyr, you'll get this, don't worry about it. It's a warning, not an error. But what matters to us is that now we've imported these functions from dplyr, and we can use them in our environment. The first function we're actually going to use is one called tbldf. And this basically converts our data frame into, oh, someone's at the door, into something called a tibble. Hey. Tibbles do have some cool advantages, but we're not really going to go over them that much. The only thing we really care about is the fact that when a data frame is a tibble, it prints out in this like much nicer format and doesn't print out the whole data frame. So what we want to do is save DS as a tibble just so it's easier to work with later on. So we do that with this. And this is valid syntax. I know it might be a little weird to think about. It's like you've got DS on both sides of this, but it'll evaluate what's on the right and save it to what's on the left. So once we run this, DS is now a tibble. And if you print DS, it prints out in this nicer format and doesn't clutter your console. Now, dplyr brings about a bunch of functions, and actually, I'll talk about one of those to begin with. So if we look at our data frame, we see that there's a bunch of columns, right? And as data frames have. But let's say we only want to keep a few of these. We don't really care about what's in the infant mortality column, which is an awful thing to say out loud. We don't care about what's in the Catholic column. We just want to keep these 3, agriculture, examination, and education. So dplyr gives us an easy way to do that. And that's done by what's called the select function. And notice that this belongs to dplyr. Like, it will not work if you haven't imported dplyr using the library function. So select, the first argument it'll take in is always the data frame you want to do this operation on. So we'll type in DS. And this is a little wonky because it's almost too simple. You just literally type out the names of the columns you care about, without quotes, just separated by commas. Also, you can like break into a new line as long as you're writing within the brackets. So what was the third one? Examination, I think. Now if we run this, you'll notice we get a new modified data frame, but it just has those 3 columns. And this is a way of like subsetting our data by column by using select. Does that make sense to everyone so far?
Should you assign it to like a different variable name so you don't use the original DS?
That's a good question. You don't have to because this doesn't actually modify DS. This is returning a whole new object. So if we actually, yeah, that's a great question. Because if we actually run select on DS, then we run DS again, we'll see it's all there. Select does not modify DS, the object that we have in memory, unless we save it back to DS by using this operator here. Does that make sense? Yeah. Awesome.
Could you
Okay.
explain to me again? I'm sorry.
Yeah, sure.
I'm slow typer. So the DS with the little arrow
Mhm.
thing, till DF.
Yeah.
DS. What was the purpose of doing that again?
It just converted the data frame to like the dplyr version of a data frame, which is basically still a data frame, but it plays nicer. And it's less of a headache because otherwise we'd keep having the entire data frame print out every time. So it's mostly
Okay,
convenience.
so it's for the dipler thing.
Yeah, the dplyr thing. Okay, making sense so far? Are there any questions? Anyone? Yeah,
So any operation, does it always create a new object or?
Yeah. Unless you assign it to something, it will not overwrite the original object. So like select is great for subsetting by columns, but what if we want to like filter by row? What if we want to filter our data frame based on a condition? What do you guys think that function might be called? I like said it a couple times. Filter. Yay. And just like select, given that this is a dplyr function, it takes a data frame as the first argument, again, because consistency is awesome. And then for the further arguments, oh yeah, what's that? Yeah. Yeah, it does. Yeah, so select is case sensitive, and it has to be like an exact match for it to pull columns. Actually, sorry, before we move on to filter, one other cool thing about select is that you can actually use minus before a column to get everything but that column. So let's say we just really don't like fertility data. Another awful thing to say out loud. And okay, it's not really showing here, but you can see the dimensions there. It's got 6 columns where it would have 7 otherwise. And these are the names of the other columns. Let's cut out fertility. Anyway, sorry, back to filter. So where with select, we were just pulling columns by name. With filter, we want to subset rows by condition, right? So let's say we let's say we just want to look at counties that have less than 20% Catholics for some reason. So the syntax for that is actually super simple. You just write Catholic, less than 20. That's literally it. You just write your condition as a further argument, and then once you print this out, you will just get, okay, you can't really see it here, but you will just get rows where, what's it called? The Catholic value is less than 20. Okay, so now we've got all these other columns. Let's say we just care about the Catholic one. What's a way we can combine select and filter? So one might think you could like take this or save this to an object and then run select on that, right? Just to get Catholic. But the other cool thing that dplyr offers, out of its many other cool things, is this thing called a pipe, which is not very helpful on its own. So I'll type it out. It looks like this. That's also not very helpful. Oh God. Wait, why is that still in here? There, sorry, add more white space. So the pipe kind of sucks to type out the first time, or the first few times.
It's called a pipe.
Yes. So I use pipe like, yeah.
It says in the console, hashtag talking about with 16 more rows. How do you look at the 16 more rows?
You can use view for that with the capital V. So if you, we'll get to that in a minute. Yeah. So what the pipe does is, actually, yeah, I was gonna say, a useful way, instead of typing up the entire, there's a cool shortcut in RStudio. On Macs, it's Command-Shift-M. So on Windows, I'm guessing Control-Shift-M. Give it a go, Windows people.
What is the Mac one?
Command-Shift-M. Windows people, is that correct? Awesome.
Yeah.
Okay. M. M for minuscule. And what the pipe will do is it'll take whatever's to the left of it and put it as input to whatever's on the right of it. So this will all come together in a second. But for a baseline example, so remember we had our seek function, right? It took, the first argument was from, the second argument was to, and then it would print out numbers from, to, and everything in between, right? So using the pipe, this is actually equivalent to this. Dot, comma, 3. It's the same thing. What the dot does is we're telling R, take 1 and put it where the dot is after the pipe. Does that make sense?
Wait.
It's a, sorry, move that out the way. Does that work for everyone? Still a little tricky? Okay.
Oh, just puts the one where the dot
It's
is?
the output of whatever's left. The dot is the output.
It'll take whatever's left, put it here, and then evaluate this whole thing.
Oh, I was just
Does that make sense? Or are we still having trouble getting this? Sure. Actually, maybe an easier example might be this. Remember we had our variable x, which just contained the number 1?
Yeah.
Print x, right? We could also just go x, pipe, print. And it's the same thing. It's kind of, yeah, it just takes what's on the left and puts it in there. Yeah, I missed the dot. So generally the dot will specify where you want it to go, but if you leave the dot out, it'll still work. It'll just put it as the first argument.
Just one argument.
Sorry?
There's just one argument to the right.
No, as long as you've got the function on the left side, it'll just toss it into the function on the right. Did we all get that concept? It's a pretty important one for like the next few minutes. Sure, it'll take whatever's on the left, like an object or something, and put it as input to the function on the right. Not always. A dot will specify, but if you don't have the dot, it'll like automatically put it as the first thing in the function. Cool?
It makes a lot more sense as you
As we move on,
what it
yeah.
does,
Okay.
and as we use it.
Yeah. So if you don't fully get it, bear with me. So what we wanted to do earlier was we wanted to just select the Catholic column, and then we wanted to filter it so that we get Catholic less than, or rows where Catholic is less than 20. So where the pipe comes in handy is, remember how ds was the first argument for each of these functions, for select and filter? This means instead of this, so where we might go select ds Catholic, we could just go ds pipe select Catholic. Right, these are the same thing, right? And I'm actually going to put this on a new line. You're allowed to put it on a new line. R will still evaluate it properly. So when I run this, I just get Catholic. And notice it's a data frame, right? But I want to filter this data frame, not the original DS, so that I just have values less than 20. And this is where the pipe comes in handy because, and this is the rub of it. So if you're not paying attention, this is a good time to start. You put the pipe at the end of this, and then you put your filter command. And since you're piping a data frame into it, you don't have to write the first, you don't have to write the data frame name again. You just write your condition. And then you run this whole thing, and there you go. So a lot just happened here. Take a second to process it.
Okay, wait. So, this might be really slow.
No, go for it.
So when you went to the next line, you just hit enter, just not command enter, and then you just ran the whole.
You can actually run, you can press Control Enter anywhere within this code block, and R will know how to deal with it. You can write this as one line. I've just split it up for readability.
Oh, okay.
Yeah. Do people get what went on here? It's a tricky concept, so don't feel bad if you didn't. What's up?
How did, in the other examples where you use the pipe, you have to indicate where the thing on the left side of the screen,
Yeah.
how can you have to indicate in this instance with the dot where the DS is supposed to be?
Right, good question. So I should have been clear about that. So you can mention the dot here. I could go dot, comma. But if you don't have the dot, it'll put it in as the first argument automatically. So the dot is a nice way to be explicit so that anyone reading your code knows what you're doing. But you could get away with not having the dot for deflower functions. Because notice how I kept saying that the data frame is always the first argument. That is totally by design. So that you can keep piping things together, and the data frame will always be the first argument. So you don't even have to worry about the DOM.
So you probably said this, but so what's happening here is that the DS is really before Catholic, and then that output from the select function being the first input in the second function filter.
Yep, you got it. Yeah, that's what's called a pipe, right? You take DS, you pipe it to filter, or I should go this way, to select. It'll take the select column, you pipe it to filter, it'll take all the values less than 20, and you're left with your truncated data frame, right? And like, notice how like easy this is to read, kind of. Once you kind of get it, you're just like, take DS, pick the Catholic column, take all the values less than 20. It like, well, it doesn't read completely like English, but like closer than, I don't know. Doesn't have scary curly brackets and stuff. Cool, okay. Is everyone's minds blown by this? Or is it just me? Okay, sweet. One last thing to mention before we move on to the other cool things is that you could, so filter can take in, actually, let me stick with the pipe notation just so we're consistent. So if you want all the, let's say, examination, the rows that have, the rows in the data frame where examination is exactly equal to 15, you have to use 2 equal signs. That's important to note. Because 2 equal signs in R means check whether these things are equal, whereas 1 equal sign is different. It's for assignment. So be careful of that. And finally, if you want to do less than and greater than, you have to do it before the equals, like that, or that. I should actually just run each of these. So 15, kind of see it here. Same goes here. So greater than or equal to 15. Finally, if you want to match a character, or so like a string of text, you would have to do it in quotes. So let's say we just want to pick, so in the X column, we have the names of the counties. We would go double equals, and then in quotes would go, let's say, I don't know, Aigle. I'm not French. And that's the way to match that. That makes sense? Are we good with filter? Okay. Sorry, one last thing to mention about it. If you want to filter with multiple things, just like with select, you just tack them on as new arguments. You go DS, filter, Catholic is less than 20, and I don't know, let's go more than 20 so we have more rows. And examination is less than 30. And then it evaluates according to both those conditions, yep? 58. Right, so we have a column in our data frame that's just called X, and it has the names of these counties. So if we want to match the text in these, the only important thing really to note here is that they have to be, the text has to be in quotes. That's mostly what I wanted to point out. So when we do multiple conditions in filter, it's kind of treated as an AND operation, as in both of these things have to be true. Sometimes we want either of these things to be true, which is called like an OR operation, I guess. My lingo might be kind of off. And for that, we use the bar key, which is, it's probably not called that. On Macs, it's the one above enter. It's like that line that you probably like never use. Yeah. I think it's usually on the same key as backslash. It should be shift backslash. Yeah. So when you do that, it returns rows that match either of these conditions, not necessarily both.
Can I see that line?
Which one? Oh yeah, sorry. I'll add a line break here. Yeah.
You can't do a double ampersand.
I think you can actually. Is that true? Like a double ampersand? Yeah.
Is that?
But it does something different. Like,
Oh.
Oh,
Okay,
I see.
I'll do it. Sorry, yeah? Oh, okay. Are we all good with this?
So wait,
This is OR. So it's like either of these can be true. Whereas if we just have a comma, it's AND, both of them. Or even like 3 or 4 if you added more conditions. Okay. So now we're going to move on into arrange. In the interest of time, let's skip over naming columns. Okay, so sometimes what we want to do is arrange our columns by a numerical value, for instance. And for that, the function, anyone want to take a guess at what it might be called? Sweet, you guys are picking up on this fast. So let's add some, I don't know, arbitrary threshold of, just so our data frame is less massive. Then we'll pipe it again. And we'll just select, I don't know, Catholic. And you can actually hit tab when you start typing the column. And sorry? Oh, sorry, yeah. If my text goes too far down, just like give me a shout, because I can't notice from here. We'll select Catholic, we'll select fertility. So, oh, sorry, I should have shrunk this a long time ago. Sorry. So now, so we've selected just Catholic and fertility, and we filtered for values that are greater than 20. What if we want to arrange this in ascending order of Catholicism, I guess? So we have our detective caps on. We figured out that it is the arrange function that does that. And again, we don't need to put in a data frame as the first argument. We just put the name of the column we want it arranged by. And then you run this whole block of code. Ta-da! Looks good? Makes sense? Am I going too fast? Sorry.
For me.
Okay.
Maybe not, maybe not sure.
Okay, as long as you're getting something out of this. Of course, sometimes we want it to be arranged in descending order. Syntax for that is a little funny, but you basically do this whole thing again. But you just put desc, short for descending, around the column you want to arrange it by. Yeah. Then you run this, and it's the same thing, just the other way around. Okay, I'm getting close to wrapping this up. One thing I actually should mention, and why I had this pane open, I totally forgot to mention, is let's say you're like, you know, you're doing all your fun dplyr stuff and you have an amazing time with your data frame, and you just completely forget how select works. You're just like, oh God, I don't know how this works, and I forgot how to Google too. Or you don't want to open your browser, which is also totally valid. So R has extensive inbuilt documentation, and it's all available appropriately through the question mark. So if you just go question mark any function, and then you just run that, it'll show up down here, called the documentation. So it'll tell you what the function does, a description, how you use it. It's pretty in-depth. I like to scroll all the way down where they've got examples, and usually just like kind of infer what's going on from there. But that's why I had that pane open for 40 minutes before remembering to do this. So yeah, this is super handy. If you ever forget anything, obviously you can Google it, probably get the same thing. But R has this built in, which is a super nifty reference. Okay. So now we're going to move on to what is my favorite dplyr function. I'm not going to make you guys guess this one. It's kind of hard to guess, but it's called mutate. Yeah, and it is as fancy as it sounds. And what mutate does is it lets you actually take the data inside your data frames and perform calculations on it to make new columns, which is like, I don't know, for me that was like, but it's a bit of a complicated function, so I'm going to type stuff out and then explain it. So let's go ds type. Let's just select.
What's it called again?
Sorry, mutate.
Mutate.
Yeah, I'll type it up in a second. Let's just pick fertility. And here, I'll type this up and then explain it. Okay, this is like a benign function. It doesn't really do anything useful, but still. Okay, I'm going to run this and I'll explain it. Okay, so what did we do here? We took our data frame. We just selected the fertility column. And then a bunch of interesting stuff happened in mutate. So let's look at this side first. This is a function, or this is an operation we're performing on the fertility column, right? And then we're saving the results of that in a new column that I just called f%. So here we're just taking like the percent value of all the numbers in fertility, which you can kind of see here, right? And what mutate does is it'll take whatever operations you've defined in the body of it, and it'll run that for every row in your data frame. This is called a window function because like it treats this entire, this whole thing is like a giant vector, and then performs the same operation on every element of that vector. So like the stuff you can do with this is like ridiculous, but this is like a benign example just to show you the syntax of that. A more useful thing is when you combo it with this cool thing called if-else. I'll do this again. So let's say our definition of infertility is if your fertility index is less than 50. So we'll define a new column called infertile, and then we'll use this thing called if-else. I'll type this out and then explain it. I'm going to move this aside just so you guys can see it a little better. I'll move it back, I promise. And I'm breaking to a new line for readability, but it's still all part of the same function. Okay. So did everyone get that down? Or everyone is still typing? Okay. Anyhow, I'm going to run this and explain it. It's a bit of a busy function. Actually, we'll deal with this. So what went on here? We took the fertility column, and then again, look at the right side first. What if else does is it'll take a condition, and if the condition is true, it'll output the first thing, which in this case is yes. Or sorry, fertility should be less than 50. That's totally not the definition of infertility. And so if the first statement is false, then it'll run else, which is the second thing I've provided, which is no, right? So here you'll notice that, what did it do? So for a fertility value of over 80, it gave a value of no, because this, this data point does not qualify as infertile. This is not very useful, so I'm gonna pipe this into view. This is something I can actually do. And it's something that's actually pretty useful to do, especially because tables don't show the whole thing. So you can set view at the very end, and we can look at the whole thing here. There's some yeses at the
You
bottom.
don't need it in the view one?
Sorry? No,
Just like view.
because view just takes a data frame, right? And the data frame is the only thing we're feeding to it. So yeah, how cool is that? Like one line of code can just like run through your entire data frame and like pull something from it, or like do a calculation on it. I don't know, that blows my mind. Okay, so we're running down to our last 5 minutes. We'll try to wrap this up really quickly. Are there any pressing questions? What just happened?
Don't worry, I have no voting later.
Okay, awesome. And remember, if you did miss something, you can talk to me after, and this whole thing is being recorded. So you can hear me going off about how cool mutate is on YouTube forever. Well, the link will be here afterwards.
Right, that's literally.
For sure. I will duck it there. I am tall. Okay, so the last thing I'm going to talk about is we'll necessitate importing tidyr. So the same way we did dplyr, we're going to import tidyr. Let me scroll up a bit. So again, we run this command. And now we've pulled in a bunch of functions that are available to us from the tidyr package. And we can use those, however much we want. In tidyr, you'll find operates really similarly to dplyr, but it's more for reshaping your data as opposed to like, subsetting it and doing like cool calculations on it. But tidyr in itself, and also like in combination with dplyr, allows you to do like pretty awesome things. So I thought I saw a hand go up. Okay, I actually totally forgot to mention something earlier. Sorry for being a little scattered. This is a completely like side note, but if you want to rename a column, you can do so using the rename. Oh God, how did I get there? You can do so using the rename function from dplyr, not from tidyr. So if we just select fertility, or sorry, not fertility. You notice how we have a column called X? That's kind of annoying. Let's call that county because that's what it is. So we'll select county. We'll pipe it to a thing that's predictably called rename. And then you just put X, or sorry, not county, sorry, you should put X here. Sorry, brain fart. And then in rename, you put the new name on the left-hand side of the equals and the old name on the right side. What you're basically telling R is pick this X column and now call it county. So if we run this, we see that it's called county now. And since this is such a common operation, the R gods have given us some pretty useful shorthand. So you can do this in the body of select itself. So you can just go select county is equal to X, and that will still do it. So that's like a handy thing to know in case your column names are like not very useful or you want them to be different for some reason.
So after you change the name, it doesn't really update the table that you have over there.
This one?
It will still be
No.
called X.
X?
Yes.
Yeah.
So then you have to close it and then create all of the information.
You haven't created a new object. So right now it's DS.
Yeah.
And that won't change until you put DS into.
So I could be like DS2 is this.
When you create a new object, basically the
Yeah.
column X and the new object will be called county and stuff.
Yes.
Yep. Yeah.
What would happen if you just didn't put the select X and just said rename county equals X? Wouldn't that Doing that technically?
It works, yeah. I just picked select X so like it would actually show up in the console. But yeah, it totally works. Yeah. Let me know if I cut any corners that make things confusing. Trying to avoid doing that. But yeah, back to tidyr and why it's super cool. So let's look at our data frame really quick again. We have in each row, we have a single county, and then the columns indicate different things about this given county, like a fertility index, an agriculture index, that sort of thing. This is what's considered, it's called a wide format. I don't know why it's called that, but it's wide if, you know, on the column names are different features of your data and the rows are different data points, or observations is the technical term. So tidyr lets us change this to what's called a long format, which is super useful for reasons I will show right now. So let's look at our data frame. I'm going to remove infant mortality because that's what Luke did in his lesson. And again, I'm just aping off his material. And we'll rename county to X, which we could also do in the body of select again, but I don't want to make the line too long. Or sorry, name X to county. And as we know, that'll look something like this, right? We've got 6 columns total, 47 rows, all that fun stuff. Now I'm just going to run this next command and then explain the magic. tidyr is based around 2 commands, 2 main ones at least. The first one is gather. And what gather will do, let me just type this up. Minus 20. I'm actually going to pipe this into view so it's easier to see. All right? Yes, sorry. Okay. So keep an eye on this function. This is the cool one I just introduced. And then at the very end, I'm sticking all this into view so we can see it much more nicely than the console would allow. Once I run that, notice what happened to our data frame. Most of our columns seem to have disappeared. But instead, we've got these 2 new columns called measure and value. And in measure, so for each county we've got, so let's say the county of, I'm not going to try to pronounce that. The fertility index is 80.2. You have fertility for each of these counties. And once you go further down enough, you have that for agriculture, and so on. So we've reshaped our data frame in a pretty significant way. And this is what's called a long format. So it's, and this is useful in tandem with dplyr for reasons that I'll show in a second. But just like take a second to appreciate what happened to our data frame here. That we took all these columns and just kind of made all of them into a new column itself. And then for each county, we save the value of that feature. That was a lot of jargon. Does that make sense? Are we all cool with that? I don't see any confused faces, or maybe I'm not looking hard enough. But regardless, so why this is useful is, oh god, it's 9. So I will try to wrap up in the next 5 minutes. I don't have much longer to go, I promise. Huh? 7. I've had a long day.
I was like, 9 o'clock.
No.
I gotta go.
Sorry.
Okay.
I have a thing in evenings that usually ends at 9. That's why I said that. So one thing, actually, might as well get this over with. To undo that, if you have something in long format, you can undo it by using spread, which is the other cool tidyr function. And here you just type in the names of your new columns, like your measure column and your value column, which in this case we name measure and column, measure and value. So if we run that in view, it looks the exact same as our original data set. So these basically cancel each other out. So if you've got data in either format and you want to flip it to the other, gather and spread are the ones that do that. So I'll just annotate this, too long, and then too wide. Remember, you can use hashtags to comment on your code. So if we just use the gathered version of our code, I'm kind of glossing over the explanation because we're like kind of running out of time. But like, again, documentation is awesome. Google is also awesome. Both of them together is even more awesome. So like, yeah. Huh? Oh, yes, thank you. So dplyr has this cool function called group by. And what group by does is hard to explain, so I will do it anyways. I'm going to explain it. remember how in our, oh, this is actually, I'm just going to do this real quick. So this is our long data set, right? You notice we have this huge chunk of rows that just have fertility as part of the measure. And same goes for agriculture and that sort of thing. So wouldn't it be super awesome if we could kind of group our data frame into like chunks based on what the measure is? So like think of take all the fertility rows, do something to that. Take all the rows that have agriculture in them and do something to that. Let's say something simple like getting the mean of all the fertility indices and getting the mean of all the agriculture indices. Like, it would be pretty cool if we could do that with, you know, some nifty simple command. Unfortunately, that is group by. So what group by will do is it'll add some kind of under the hood grouping information that will like modify your data frame in ways you can see, but to R, like under the hood, it'll know that something's going on there, that you're grouping these together. And that's why I put measure. So measure is the only real argument here because that's what I'm telling R to look for groups with. And group by on its own is not super useful, but in combination with summarize, it becomes super powerful. So summarize, much like mutate, I will write a name of a new column, so let's call that average. And then I'll use the mean function, which is pretty self-explanatory, and go mean value, because I want to compute the mean of the values in this column. This is a reminder. Following along with me so far? Okay, that ends up looking like this. That's it. That's the entire data frame it outputs. So notice what it did here. It took all the rows that had agriculture and computed the mean of those values. All the rows that had Catholic computed the mean of all of those. And it output a new data frame for us to like quickly see the summarized data in. Does everyone get what went on here? Okay, cool. So this is like pretty neat. You can like pull in a data frame. You can pick, you know, the rows you want, turn to this long format, and then like summarize by index with like a single line, as opposed to like running it on each column or something like mundane like that. So summarize has a host of helper functions that you could use. One that I use quite a bit is just n, which counts the amount of observations we have. So we can actually just add that onto here. I don't know why I copied this again. So I'm going to do it on a new line. Count is equal to n with brackets. That's the entire function. N with brackets just means count the number of things that are in there.
Can you do this only for like say 2 of the 5?
Sorry?
Can you like do this function only for say 2 of the 5 measures? Or
Yeah. So what you would do is you'd take DS and then use select just to get the measures you want, then gather, and then, yeah. So once I run this, with summarize, I could just add new columns as new arguments, and then I get that in my data frame. So each of these has 47, which makes sense given that our original unchanged data frame had 47, but that's still useful information sometimes. And summarize has like, mutate too, has a lot of other like useful functions. You can get the mean, standard deviation, all that sort of thing. I mean, all those sorts of things. But given that we're kind of out of time, I will leave that to you guys' exploration. Are there any final questions before we wrap up? Anything pressing? Yeah? Of the entire thing? Like the entire data frame without grouping it?
Yeah.
Yeah. Oh, yeah, actually, I should have mentioned that earlier. You can just remove group by. So I can actually comment that out, which is a useful practice to have in coding. So again, I added the hashtag there, so it's not reading this as code. It's pretending it's a comment, and just R will not see that there. So when I comment that out, I just get the average of the whole thing, which is this, and count of the whole thing, which is 235. So you can run that without group by to get like an entire data frame wide summary statistic, or 2 or 3 or however many you want. Do you guys get what happened here?
Yeah.
Yeah, it was just, I didn't have any grouping information, so summarize just took the entire data frame and just got the mean of everything in the value thing, in the value column. And then it took the count of, again, everything in the value column, which is 235. Okay, this was a lot of information. How are we all feeling? Do we feel pretty good about R? Is R pretty cool? Thank you. That's the main important thing. Yeah, okay, I guess I'll wrap it up here. Thank you guys for coming. This is like a record crowd for coders, I'm pretty sure, which is super awesome. And it was like super fun being being up here teaching you guys for that. So yeah, thank you.